everybody. Cool. Now's your time to get it. So I saw a lot of weirdness surrounding two terms that sound very similar but are very, very different. The nth term versus convergence of a series. The nth term is just a single number, the nth number in the series. But when I talk about convergence of a series, I'm talking about the sum of all of the terms in the series. So let's look at how this difference plays out. Let's say I ask, does the series from 1 to infinity of n over n plus 1 converge? First, you always want to imagine, what does this series actually look like if you were going to expand it? Based on what a lot of people said on their tests, you would say yes, but the answer is actually no. And I think the confusion here is people looked at this expression and ignored the summation entirely and said, oh, when n is really large, this is very close to 1, so yes, it converges. But the confusion is, what you're trying to say is that the nth term is approaching a particular value. So if you wanted to write that down with the correct mathematical notation, what you're really saying is the nth term as n approaches infinity equals 1. So the limit is equal to 1. And that's just a different way of saying as the terms get larger, they're getting closer and closer to 1. But if I ask, does the series converge, I want to know what's the sum of all of them. And if you're adding more and more and more numbers that are closer and closer to 1, your sum is just going to keep getting larger and larger and larger, when that means it's diverging. The situation would be very different if I asked this very similar sounding question. Let's let a sub n be a sequence whose partial sums are given by that same equation. And now I want to know, does the series defined by the sequence converge? In other words, if I take all of the terms from this sequence and I add them all up, is that a convergent series? So the big difference here is now this equation isn't telling me what an individual number in the sum is. This is telling me the nth partial sum. And the nth partial sum is the sum of the first n numbers. So now I'm saying, like, let's say n was 1,000,000. The nth partial sum would be 1,000,000 over 1,000,001. And that's very, very close to 1. But that's not telling me that the millionth number in the sum is close to 1. That's telling me the sum of the first million numbers, all of them together, when I add them up, are close to 1. And that's practically the definition of convergence. So you see, they're two very slightly different things. Well, they sound very slightly different, but they're describing completely different things. And I hope you know by now, most of my tests are not designed to see if you can look things up. My tests are designed to see if you can think clearly about what you're doing, whatever it is. And so that, I think, is the place where a lot of people went wrong, is you weren't paying attention to small details that make a big difference. Almost the exact same confusion came up in the question where I asked for the equation for the nth term in an arithmetic sequence or a geometric sequence. I saw a lot of people give the equation for the sum of the first n terms, not for what is the nth term. And again, maybe you just misread, but it makes me very nervous, you're just doing stuff without actually thinking about what you're doing. Just to review real quick, though, for things like that, no memorization is even required. It's almost like middle school level math. In order to know what the nth term is, we're starting somewhere, and we're adding 11 a bunch of times. Here, this arithmetic sequence has a constant growth of 11. So if I want to know what's the nth term, I say, all right, let's start at -5. Let's add 11 a certain number of times. How many times? Well, here is the fourth term. I have to add 3 11s to get to there. So if I'm going to the nth term, I have to add n minus 1 11s to get to there. And that's it. No memorization required. Same thing here. Here, the constant ratio is 1/2. Which means that I'm multiplying by 1/2 to get from one term to the next. So the equation for the nth term would be, let's start at 3, then let's multiply by 1/2 a bunch of times. And for the same reason as before, I'm multiplying by 1/2 n minus 1 times. And that's it. No memorization required. I saw a lot of weirdness for this kind of problem also. Sum the first 6 terms in the arithmetic series where the 100th term is something and the 200th term is something else. Again, I saw a lot of things that felt like plugging and chugging with no thinking to me. But it's really, really straightforward if you just think about what are these things actually saying. So like, here's what happens in my head. I've got this series. I don't know what the beginning of it is, but I know the 100th term is this and the 200th term is that. I know because it's an arithmetic series that each term has a constant growth from the previous term. Let's call that D. So if I want to figure out what that growth is, all I have to do is say, okay, so I'm starting at 58, and 58 plus a certain number of D's is going to get me to 868, right? I'm starting somewhere, I'm adding something a bunch of times, and that's equal to my next thing. Well, how many times am I adding D? To get from the 100th term to the 200th term, I'm adding 100 D's. And now you can just solve for D. So like what? 868 minus 58 is 810, is that right? Yeah. So that, and then divided by 100 equals D. So that means D equals 8.1. Cool. All right, well, how would you find the first term in this series? It's like the same thinking all over again. Let's call this A. So I'm starting at A, and I know that if I add a certain number of 8.1s, I'm going to end up here at the 100th term. So how many do I have to add? To get to the 100th term, I have to add 99 of them. So I'm going to add 99 8.1s, and then that's equal to 58. And again, you can just solve for A. So the process here, it's not about equations, it's just about thinking in a very kind of simple-minded, straightforward way.